Hi, this is Sarah. Say hi, Sarah. Sarah has a mutation that makes her stomach full of weak acid. This makes her very hungry all the time. But what can Sarah possibly eat to satisfy her hunger? Won't you look at that? Box of basic deluxe cookies. Wow. Although Sarah might look like she's in a pickle while opening the package, Sarah is determined and decided to eat all of them cookies. How do those cookies smell, Sarah? Good? Before Sarah devours those cookies, let's talk about the process of mixing weak acid and strong base. Here we have a basic titration curve. The initial point where no base has been added will always be in the acidic range. As base is being added, the acidity continues to decrease till we arrive to the equivalence point, where a dramatic pH change occurs. The equivalence point occurs when the solution is at equilibrium, which means that the moles of acid equals the moles of base. Half of the volume it took to arrive to the equivalence point is also known as the midpoint. A buffer region is created by gradually adding base while the pH of the acid slowly rises. After arriving at the equivalence point and more base is being added, an excess region is created where the basic pH is not affected. In this titration curve, the cookies eaten by Sarah will act as a strong base, while Sarah's stomach will act as the weak acid. At the beginning, when no cookies have been eaten, she finds herself at the initial point. As Sarah begins to eat the cookies, she'll find herself at the buffer region. Once Sarah feels as if she's full, she has now arrived at the equivalence point. Sarah being half full will represent the midpoint. As Sarah continues to eat and eat and eat all those cookies after being full, she'll find herself at the excess region. Whoa, Sarah, before you dive in, we have to talk about one more thing. This is how to perform a basic titration. The strong base is placed in the burette, while the weak acid is placed in an Erlenmeyer flask. As base is added, the pH and volume increases, and the acid becomes titrated. For this titration, the cookies represent the base, and Sarah represents the acid. Sarah's stomach has a concentration of 1.0 molar and 30 milliliters of acid. To find the pH at the initial point, you multiply the molarity of the acid by the volume of the acid and take the negative log of that. When a solution contains acid and its conjugate base, or base and its conjugate acid, we call this solution a buffer solution. As stated before, the volume at the midpoint is half the equivalence point. Find your moles of base added and use it to find the amount of acid and conjugate base in the solution. Then, by using the Ka and the Henderson-Hasselbalch equation, the pH can be calculated. Finding the pH at the equivalence point can be tricky. Since your moles of acid and your moles of base are equal, there is only conjugate base left in the solution. Convert your Ka to Kb and then use the mass of the conjugate base to find the pH. Use the moles of base and divide it by the entire volume to obtain the concentration of the base. Use this to calculate the pH of the excess region. Oh no, it looks like Sarah ate too many cookies. She's definitely at the excess point now. Don't you think so? Ew.
Nobody was harmed in the filming of this video. She decided to eat all the cookies herself. We told her not to eat all the cookies, however, she did not listen. She continued to eat cookie after cookie after cookie after cookie after cookie after cookie, and just kept eating the cookies till she reached the last cookie.